It's asking you to find the values. What are the approximate values of f of x? So what you're looking at here is at f of negative 1. F of x is 1, 2, 3, 4.
Okay, that's what I had, but it says something completely different. Oh, wait, never mind. I looked at it myself. But like it said, like equations in the back of the book for like the other one that was similar to it.
Yeah, because they were given the equations. You're trying to do the equations given that stuff. All right, and if you go to 0, what's the value of f of x at 0? 2. This is a cubic function that's been shifted. And we'll talk about the shifted graphs and the h's and k's and this stuff. Probably not so much today. We'll probably start that graphing pack stuff tomorrow in 1.6. I got something different for us to look at today. F of 2, it's just substituting in what does it look like it appears to be. I know it's not going to be perfect. I think I was saying it looks like it's about 3 at that point. And then f of 1 is at 0. Does that make sense?
Yeah. It was like, I thought like, what was that, like 2? I thought it'd be like positive 50.
I see what you're saying. Yeah. It's tough to visualize where you're at. And then, yeah, that was that one. What was the other one in there? 18?
Yeah.
Find the zeros.
18.
Remember, when you're finding zeros of a function, all you're doing is setting the function equal to 0. So, I get 0 equals x squared minus 9x plus 14 all over 4x. Now, isn't this the same problem if I do this?
Yes.
Isn't that now fraction equal fraction?
Yes.
When you have fraction equal fraction, what do? You cross multiply. So what's 0 times 4x? 0. There's 0. You don't have to put the x there because it's redundant at that point. So now all you have is 0 equals x squared minus 9x plus 14. What times what is positive 14? You add together, get negative 9. So your zeros are at? Where are your zeros?
At 7 and 2.
Perfect.
Yes.
That's your solution. What is your domain restriction on this one? Very good. My domain restriction here, guys, my domain restriction here is 0 because I can't have 0 in the denominator. Okay. All right. What else? Grouping. Factor by grouping. Trick here is you've got 4 terms. Descending powers. Factor it by grouping. Go GCFs.
2.
GCF here is going to be 4x squared. So I have x plus, excuse me, x minus 6. Yo. Yeah.
Me?
Yeah.
Wait, when did you distribute that negative and be negative 6? Yes. 2? That's what I messed up on.
Yeah, that'd be negative 1, then I have an x minus 6. When you have that third term is minus x, I always do the same change opposite to when I group it to remind myself to pull the negative out. Okay? It's a huge common mistake that you guys will do. Doing it that way will force you. Now you've got 4x squared minus 1 and x minus 6. And can you factor? No. Can you factor that further?
2.
Is 4 a perfect square?
Yeah.
Is 1 a perfect square?
Yes.
Is that a subtraction symbol?
Yes.
So your 2 terms are?
2x and 1. 2x.
And your zeros are at plus or minus 1/2 and 6. Yeah, you could have done it where you had 4x squared minus 1 and then just set it equals 0 and take your square root. You get the same result. That's fine. But a lot of times when people do that, you'll forget to do plus minus.
But I did it.
Excellent.
Thanks, shout out to
Shout out to you.
you. Top me up.
One more. Is 9 a perfect square?
Okay, then don't do that one.
Wait, but can you do 20?
You can do 20 instead.
It's a grouping problem.
Okay, then.
Yep. 9 is the same problem, or 20 is the same basic thing. X cubed minus 4x squared minus 9x plus 36. Group them. There's your x squared. Same change, opposite. Take out the negative 9. And here's your x minus 4. And you wind up with x squared minus 9, so you have x plus 3. Yeah, Jenna?
I'm 20 years old with that one.
And that's what you wind up with.
Is this 20?
Yeah, that was 20. Hi. Long time no see. Welcome. So you have zeros. It's the same problem.
Can we do something from day 20?
Yeah, I want to go to day 2 here. Now,
I need to do like all of them.
Yeah. Every single problem.
there's a couple of parts of day 2 I want to talk about. Day 2 stuff, when you had your average rate of change. When you're talking about average rate of change in day 2, what this is the change in f of x, change in the function, divided by the change in x. So if you're looking at number 65, for example, it said x squared plus 12x minus 4 is your f of x. And your two x values they want you to look at are between 1 and 5. So I know that I need to find the change in f of x. Well, in order to do that, I'm going to take the change in f of 5 and subtract, well, not change, just take f of 5, subtract f of 1. X sub 2 would relate to y sub 2. Y sub 2 is basically the same thing as f of x. It's the same idea. It's slope. Change in y, change in x. So if you substitute in 5 in here, we get 5 squared plus 12 times 5 and minus 4. 25 and 60 is 85. 85 minus 4 is 81. So I know that my numerator will be 81 minus 1 squared plus 12 times 1 minus 4. Well, what's 13 minus 4? Over 5 minus 1.
So, the answer is 18.
You get 18. Your average rate of change is 18. What this is, I'll get you 1 second. What this is that you are looking at a curve of the parabola, and you're picking two values. The slope between those two values is 18. What you're looking at here is called the slope of the secant line. If you recall from geometry, a secant line was the line that went through the circle. It touched on both sides and continued. Not the tangent line where it touched at one spot. The stuff you guys did with remember we did f of x, the x plus h, the difference quotient? The difference quotient is the slope of the tangent line. The average rate of change is the slope of the secant line. A little bit difference. Okay. Just know that, but it's just different. That's all that looked like. It was direct substitution in division. Watch your signs with the negatives in parentheses. That's all I can think of. Yeah. You might as well like that stuff. Yes. You were the victory again because you're like awesome guys. Yes, you did. Yes, you did. Your sister's gotta stop playing volleyball.
Oh, I'm so sad this time.
Oh, I didn't make it. Oh, yeah, I did. There's my head right there in the corner.
Luke Davis.
Hey, that was a good idea. We've started to finally put your face on the ball your sister's hitting. Well, wait, there's more. It's you and JC.
No, JC,
Yeah, I have to save this one, so we're gonna get a dual sign. No. I'll print them off later. Devin.
How do you like find these? Like you?
I eat breakfast, which is good. And you want to eat breakfast, I usually read the paper. And instead of going outside to get the actual physical paper, there's this thing called the internet. And I just, I hear it's on computers. And I just read the paper. I read the paper while I'm eating my fried eggs.
You know what the URL
For the internet? www.internet.com. So yeah, that's how these things worked out. The biggest mistake you make are with your signs. Okay. The other part on here that I don't think we had time to talk about was even and odd functions. Even and odd. Oh, I'm sorry. You had a question. Boz, you had a question? You had a question a second ago. Didn't you have? Well, I swear. I know you didn't have one. I swear you said this. Oh, give me 1 second.
Oh, I was one switch.
Well, good. I'm glad you have a stretch. Okay. Anyway, even and odd functions. You may or may not have seen some of that last year. It's one of those things that you can work with. What happens is, if it's even, it has symmetry with respect to the y-axis. It can fold in on itself like this. Okay. Y-axis goes up and down. If I take that, I can take the button. I can do that, and then I can flip it onto itself, and it's a mirrored image.
Oh.
That's what that means. It's a mirrored image of itself on just one side. What about the y-axis? Parabolas are like that. And why is a parabola like that? Because what's the degree? It's a squared column. What happens here is that you know that you're going to wind up being even if there's a little property here. And this is what you're looking at. It's just ridiculously easy to work with.
So all we have to do is.
You're substituting a -1 for x.
That's it.
That's it.
But
And if you get an equivalent statement, it's even. And if you get an opposite statement, it's odd. It's that easy. What happens here is if I look at a function, just x squared, f of x equals x squared. And I want to check and see if it's even or odd. What I'm doing here is I'm taking this negative x and substituting it into here. Is negative x squared equal to x squared?
it is.
It is. So is x squared an even or an odd function? Even, it's an even function. That's what that means. Okay? That's all that means. Let me show you, 71 was a problem you guys had to do. And let's walk through it. Here's 71. F of x is x to the 6th minus 2x squared plus 3. Now, what this is asking you, it's even if I take f of negative x and I still get f of x, if nothing changes. If I substitute a negative x into these values, will I get the exact same equation when I'm done? You're shaking your head. Why are you shaking your head?
Because you say f(x) is negative.
No, I said f of negative x.
Oh,
Okay. So if I take this, parentheses negative x to the 6th minus 2 parentheses negative x squared plus 3.
Yeah.
When I have a negative value to an even power, what will my value always be?
They're all positive.
Positive, that's what I'm looking at. Any negative value to an even power will always be positive. Negative 3 squared is 9. Negative 3 to the 4th power is 81. Negative 3 to the 6th power is a bigger number, but it's positive. Okay?
You wanted us to think that you're gonna know the answer, but then you didn't.
It ends in a 1.
This one got terrible.
What's 81 times 81? Has to end in a 1.
Oh. Hey, bro.
Do you want to know the answer?
What is it? Is it 641? No, it's not.
It wouldn't be that easy.
6,561.
Told you there was one, and it's a 1. So what happens there is that it becomes an even, it's an even function because when you substitute in negative x and you do the same exponents, you get an equivalent of the original function. Therefore, it's even. You do the same thing with, you're saying, look at 72. What's different with number 72, I think it's f of x is it x?
Wait, what number is this?
This is 72, I believe.
Oh, that's an odd one.
Can you give us
Because,
another date?
because if you plug in negative 1, it equals 1. But no, if you positive 1, it equals 1. But then negative 1 equals negative 6.
What?
Yes.
Oh, yeah, I see what you're saying. All you have to do is look at the negative value. Just put a negative x in for f of x, in for here. Is that going to be a positive or a negative value? It's going to be negative, so therefore will it equal each other? Nope.
Okay,
So now-
what symmetry would it be? That's the real question.
Wait, so.
What happened?
It's an odd.
Well, let's go back to the original basic idea here. If it's odd, if it winds up being the exact same thing as taking a negative times the function, it's a little different. Negative times the function. So you're odd. Remember that?
If and only.
If and only if. Geometry? Long time.
Yeah, that's an odd.
And like what you were doing, you're taking that negative 1 and substituting in. When you take that and you go through the negative 1 for our f of x. I'm sorry, it's 1. If I check it with the original function, negative x cubed minus 5. If I do that, I get negative 1 x cubed minus 5. For lack of better terms, it's going to be a negative out front. Everybody okay with that? No. Watch. It says that it has to equal negative times the function. Well, does this equal negative times x cubed minus 5? Which means I would have to distribute the negative to both parts.
So that would make it positive 5, but it doesn't. It's not positive 5, so it's not.
It's not odd or even.
It's neither.
It's neither.
No symmetry.
And exactly. So you get to this, you get negative 1 x cubed plus 5. These are not equivalent. Since they are not equivalent, there is no symmetry. Okay? This would be an example of no symmetry.
So if it's even, it's going to be over the y-axis. If it's odd, it's going to be over x.
Origin.
Origin.
Yeah. Because if I go back and I look at, the reason this became neither is because of the constant that was thrown in there. Okay? Since there was a constant thrown in there, that -5, that means it's been shifted. It was shifted vertically downward 5 spots. If you've been shifted vertically 5 spots down, you're no longer at the origin, are you? That's why it doesn't work.
Can we do one? I just we got to do it. It was x outside of the square root, and there was a 1 minus x squared and x squared.
Oh, was that one of the homework problems?
Yeah, it was 74. I just don't.
Oh, 74?
That automatically be odd because if you do negative, because you negative in front of the square root. So
Ah, let me show you. 74.
say I will look at it.
You have f of x is x root 1 minus x squared.
Yes, sir.
Okay. You want to check whether or not it's even or odd. So if we check even, that means is f of negative x equal to f of x? Well, you can see right away that's not going to work. Because if I put that negative out front of the radical, I can't square it to make it a positive again at all, can I? So I know that's not even. Everybody okay with that? So I know it's not going to work, so I skip it and I go to odd. Well, is f of negative x equal to negative f of x? When I substitute in for that, we check. Substitute negative x, so negative x square root 1 minus negative x squared. In this problem here, I can go ahead and simplify the underneath the radical. What's negative x squared?
Negative x squared.
It's just x squared. Yeah, minus x squared. It doesn't change anything. So it becomes negative x square root 1 minus x squared. Well, did that equal a negative times x?
Yes.
Yes, it will, because this is a monomial, ugly one if that, then all you're doing is multiplying by -1. Are those two the same?
Yeah.
So therefore it is odd.
And then
It's an odd function.
Oh, the origin symmetry.
Yeah, it has origin, symmetry through the origin. And if you want to get really rambunctious and look at it, what was it? X roots. I'll show you. Well, I can change that window a bit. I'm going to change this. If it's an odd function, it's symmetrical at the origin. If it's an even function, it's symmetrical about the y-axis. Okay? So if you look at that, it's got symmetry about the origin, which means I could take this part and flip it over the other one. That's all that means. What? It's a matter of substituting in -1s for it, like you those guys are doing. You get equivalencies. That's all it is. Okay. Was there another one of the odd ones that you had to do? I don't remember off the top of my
It was
head.
just 71 through 75.
So 75. We didn't do 75 yet. So let's check 75.
It's easy. It's just easy. Listen. Easy way to look at it.
Okay. So if I'm checking to see if this is even or odd, I'm checking, well, even is f of negative x equal to f of x. You could probably look at that right away and say, no. Because if I substituted a negative value into this term here, it's going to automatically make it negative, which means it's not going to be the same. Okay? So I know it's not going to work. If I check it D not, what is this? f of negative x, does it equal negative f of x?
Oh.
Remember, what you're doing for this part here is taking the negative times the whole function. So you have negative x squared minus 2x plus 3.
And then
On the other side, you go back in again, you know you're going to get x squared minus 2x plus 3. That negative, it's a negative 1 times the x squared. Does it make it equivalent? Okay. Plus, what kind of curve is that?
that is a.
What is up? You're right on that, I'll give you that. What's that called? It's a parabola, very good. Well, a parabola that has a shift to it, it's got a 2x and a 3, is that going to be centered around the origin?
No.
No.
Wait.
Yes,
What
sir.
is what is a hyperbola look like?
The hyperbola was the one that you had.
What? That's not hyperbola. What I was thinking.
Remember how much fun these things were? Slant asymptotes,
Oh, no, let's not bring that up.
this, focus, and all that junk.
So we have to do a direct translation.
Not everybody did that. It's easy. It's a formula, man. It's a formula. There's nothing to it.
It's hard to remember all of them.
I'm telling you, if you can do some of the other stuff, you'll be all right. So let's do this. What I wanted to do today is I wanted to, before we get into a lot of the graphs, I think I've done all these now, haven't I? Yeah, which one haven't you done that?
We can actually start on 77.
77.
But we can just go to 77 through 80.
Yeah, we should do that.
Yeah.
Oh, this is the wrong sheet. No wonder I'm looking at the wrong one. Before we get in here, 2 marks, because we have what, 77 through 83? Okay. Here's what I want to look at. What's this? Better yet, a tape measure, right? Sure. Now, if you wanted to measure the overall height of something, it would be from one spot to another to a height, correct?
Yeah.
Well, what happens if that height of something is standing on a chair? Does my physical height of what I really am change?
No.
Why?
Because
Still you.
you
Okay.
didn't grow longer.
If I didn't grow, what would I have to do?
Subtract
To the ground.
the chair.
Subtract the chair from the overall height that I am to figure out how tall I am, right?
Wait, technically, you would add.
Subtract? How would you add it?
Am I 8 foot something?
No, I'm saying.
Right now I am, but am I really 8 foot something?
Oh, I think you how you were when you're staying on the
Oh, okay. So here's what's happening.
That's so tall. Imagine someone being that tall.
That'd be wrong.
No,
How would it be wrong?
You wouldn't find it clothes. Yeah, clothes or someone to
Oh,
like.
but you go have millions of dollars because you could be in any professional sport if you're 8 feet tall.
Yeah, just because it's long as you're
Yeah, but
athletic.
sometimes.
Hey, I'll tell you this.
They're probably more clumsy.
I'll tell you this right now. It is hard to find dress shirts that fit my arms. You guys will find that out. You tall guys, as you get older. You're tall, skinny
You hug
guys.
each other like this.
Want to be hug? As you get into this, the wingspan doesn't necessarily mean girth as a
that word.
Yeah, what does that word even mean?
the width of your torso, if you will.
Oh.
So as you buy dress
It's
shirts,
better than girth.
the longer your arms are, you need a larger shirt usually. Well, I don't need an extra large shirt because it gets a little bit. I'm not extra large, but I have really long arms, so it's difficult to fit long arms.
If he was like a girl and he had to be like the short.
It's so woe is me. Anyway, what changes about measuring
His
heights?
shorts would be like, I just.
What changes? Nothing. ladies and gentlemen, you have two things to measure from. If you need to measure the height of the blue area here, what they're asking you to do, what is the overall curve? Let's look at the curve. What is the equation for the overall curve?
Negative x squared, no?
Yes.
Plus 4x minus 1.
If that's the overall height, here's me standing on the chair.
The chair.
What do I have to subtract out?
The chair.
The big butt chair.
Oh, here, my bad.
What's the equation of the big butt chair?
Negative x squared plus 4x minus 3.
H equals negative x squared plus 4x minus 3.
Those are ordered pairs, guys. Those are ordered pairs. Okay. Those are ordered pairs. What is the equation of the bottom?
There's an equation.
This was a little difficult.
X, negative x
Y equals 2.
Why is it minus 3?
Why is it minus 3?
Because the top.
The
Never mind.
I just said
Minus 2 because it starts at the 2 and it goes up 1. No.
What is this equation, guys?
X equals 2. Y.
Y equals 2, isn't it?
Yeah. I
So
was right.
the bottom equation you would subtract out
Minus
is
2.
minus 2. That's why I asked you why is it minus 3.
I was
You take the top equation and you subtract the bottom. That gives you the distance between the two. There's your height. That's the height of
So
that
that's all we have
sheet.
to figure out.
That's why I said it. How tall am I really? Well, subtract the chair.
How tall are you? I'm just
I'm fine.
like fine.
That's like perfect now.
I wish I was a little taller.
Even at my height, when I had a sunroof in my Suburban, my head would still hit the roof.
That's like 6'2", 6'3".
You said it was suburban.
When you had a sunroof, when I had a sunroof, the thing in my head would touch the sunroof because it cuts it out.
Yeah.
That's a big suburban.
Yeah.
You're a big man.
That's why I don't have my Suburban anymore. I have a regular truck without a sunroof, and it fits better. So, what I want you guys to
When I
do,
leave it open when it rains.
real fast, take a look at what would change measuring the length going from left to right. Take a look at this. If I'm going to measure the length of this,
Wait, we only needed to do the odd one.
I know, but I've had you do different ones.
I didn't even do any of them.
Well, now you should know how. If I'm going to measure the length of this, well, is it measuring height? Same thing as measuring length, is just falling over?
Yeah.
So if I fall over on my chair, and you still need to measure how tall I am, wouldn't you still measure my height and subtract the chair? It's the same thing, guys. So here, if I want to measure this length, wouldn't it be the far equation subtract the close equation?
Yeah.
Wait, the far equation minus the close equation?
So what's the equation of the far one? X equals 2. Excellent. And what's the close equation? The cube root of 2y.
Wait,
Why?
Wait. How'd you get that part equation?
You got it. The vertical line goes through 2.
length.
It goes through 2. It's a vertical line. It does
Height.
it. That's all it is, guys. There are 8 problems on that side of the page. 77 through what? 84 in that neighborhood. Get those 8 done, and we'll collect all of it tomorrow. And we'll do the graph. We'll start the graph stuff tomorrow. Okay.
We only had to do 77 through 83.
Now you
Well,
just
now
have
you
to
gotta
do
do
all.
4 more. Wah, wah, wah.
I got
Okay. So all I have done to this assignment, as of right now, these 4 of these problems were already given to you. 77, 79, 81, 83. I'm asking you to do 4 more of those
Go back to 82 so I can.
now that you know how to do that.
It's just a.
Okay?
Okay, can you come up to my desk?
Okay?
Wait, can you leave it out?